Hi, today I'm going to talk about the basics of two-dimensional graphics in Mathematica. Um, Before we get started, I'd like to talk about some of the key aspects of doing 2D objects in Mathematica. And one of the key aspects is that when you're building the graphics, you're going to be adding a circle here, a square there, maybe some lines. You're going to build them piece by piece. Each of those objects, the square, the circle, the line, is called a primitive. And when you're building them, you wrap all of this list of primitives in the graphics command. That's the way you get the Mathematica to display the scene that you've created. So it layers them from first to last in the list. So if you put the circle first and you put the square second and the square overlaps with the circle, well, you'll see the circle behind the square and vice versa. So you'll want to be a little bit careful about the order in which you place your primitives. Another thing about Mathematica is that there's so many different options available for how you want your graphics to look, and we'll go through some of them, including color. You might ask the question, hey, can I make my object look like this? And my answer to that is probably. You should search in the documentation center, you should go and search Stack Exchange. There's probably somebody who's done what you want to do. Otherwise, you've got a cool research project on your hands. Another thing is that when you're creating something in Mathematica and you're creating a scene, this is a little bit different from what you might have done in some other computer-aided design programs. Here, it will require thinking very mathematically because you need to decide exactly where you're going to place each of your primitives. You need to know exactly what the coordinates are for each of the primitives. You have to think, okay, there's the XY coordinate for if you're making something in 2 dimensions, or an XYZ coordinate in 3 dimensions, and you have to plan that out. You have to figure out, well, where are all the points going to go? And you might have to use some math. You might be using trigonometry to place points on a circle. You might put points on an elliptic curve if you want to use some higher math. One of the nice things is you can use all the capabilities of Mathematica to then create the graphics exactly the way you want to. The last thing is the show command. If you want to display multiple objects together, you would use show. The thing you have to be careful about is that show ends up inheriting the settings of the first graphic. So if you wanted to, you might end up saying show, but not everything appears. That's probably because the option about what is being viewed is inherited from the first graphic and it doesn't include everything. I'll talk about that in a little bit. All right, so before we get to 2 dimensions, let's start off with 0 dimensions. So when we think about 0 dimensions, we think about points. So a point is a 0-dimensional object. You use 1 point using the point command. So when you do a point of 0, 0, we're putting a point at 0, 0. And we can use the graphics object to, hey look, there's our point at 0, 0. Of course, this isn't 0-dimensional. If it were 0-dimensional, we wouldn't be able to see it. This is a 2-dimensional view of a representation of this point at 0, 0. So you might think, hey, let's make 2 points now. So let's make a point where we have point at 0, 0 and a point at 1, 1. All right, if we do this, Mathematics is throwing a fit. And the reason why Mathematica is throwing a fit is because graphics only takes one object as input. So when you look at this, it's telling us the option was not in the form of a rule. what does that mean? It's really saying there's supposed to be one input, everything else is an option, so this isn't an option. Okay, so when we want to display more than one thing, we should put everything in a list. So here we have a graphics of 2 points, 0.00 and 0.11, and now we have both of those objects here, 0.00, 0.11. If you want to do more than 1 or 2 or 3, you probably want to use the map command. So if you want to place objects algorithmically, use this map command. So here's a list of points, 0, 0, 1, 1, 2, 0, 3, 1, 4, 0, 5, 1, etc. And what I'm going to do is I'm going to apply the map function, which is going to apply point to each thing in the point list. So we get point of 0, 0, point of 1, 1, point of 2, 0, etc. And then we use the graphics command, wrap that around, and it displays all of our points. 0, 0, 1, 0, 2, 0, 3, 1, 4, 0, 5, 1, etc. What you should go and do now is go and look at the Documentation Center entry for point. Go to the bottom and look at the neat examples. There's cool things you can do with points. All right, so let's move on to color. So we've got these zero-dimensional objects. Let's spice them up by adding in some colors. So how do we add color? So to add color, for many things in Mathematica, these different directives that you want to change a primitive, you have to always place the color name before the primitive. So let's look at this example, and then let me say some of these things up here. So here's a graphics object. It's a list of things. We'd like to put a point at 0, 0, and we'd like to make it red. So make this small. So here we have just the point that's red. And so certain colors are predefined, like red, orange, yellow, green, blue. There are some others. You can check here in the color guide. You can also specify any color. You can use your ASCII colors if you're used to those by applying RGB color. And you can make colors lighter or darker, or you can blend colors using blend. There's many different things that you can do to colors. You should go and look at the guide. So one of the things is that you may want one of your objects to be red, and one of your objects to be orange, and one of them to be yellow. In order to do that, what I said before, you put the directives beforehand, and so you say, okay, I want a red point, I want an orange point, and I want a yellow point at different positions. Well, when you place this directive inside a list that has the point, it only applies to the primitives that are in the list. So let me break this down a little bit less, and then we'll go look at this larger example. So first thing I'm going to do is I'm going to have this point size 0.2, and that's going to make our point that is at 0, 0 a little bit bigger so we can see it better. All right, so that's our point at 0, 0. The next thing I'd like to do is I'd like to make it red. So I put red there before it, and now that point is 0. That point at 0, 0 is red. Now if I put the point at 1, 0 here, what I'm getting is, all right, so the point at 0, 0 is red, but because this point came after red, it's also red. And let's put in one more point at 2, 0. It's also red. So one thing we can do, let's say we only want to make the first point red. Well, we can put this in braces. We can put red, comma, point, 0, 0 in braces. And now this directive only applies to the point 0, 0. It doesn't apply to anything outside the braces. You'll notice that point size 0.2 comes before the first primitive and the second primitive and the third primitive. So all of the points have the same point size, but on the other hand, only the first point is red. All right, so if we'd like to make the different colors the different points different colors, then what we could do, one thing we could do is you say, okay, this first point is red, the second point is orange, and the third point is yellow. Okay, I highly suggest that if you're going to, basically the orange overwrites the red, and then the yellow overwrites the orange in terms of being the color that comes for all primitives afterward. What I suggest that you do is, so first, add in some white space so you can see what's happening. And then, because you really only want red to apply to this point, put that in a list. Similarly for orange. We only want orange to apply to the second one. We put that in a list. Same thing with yellow. We only want that to apply here. This doesn't change what the output is, but it makes it A, more readable, and B, it makes it so if you put something later, it's not going to have any of these options applied to it. Here's an example of what happens if you say, okay, this red, maybe this red is a bit too bright, so I'm going to lighten it up a little bit, make it a little pinker. Maybe I think this yellow is also too bright, but I'm going to darken it so it's more of a gold or dusty yellow color. That would be darkening the yellow. You can darken it by different amounts, by a little bit or by a lot. It's very, very black. So there we go. So here's different colors. And like I said, there's a number of different things you can do with these colors. One thing you can do, so one way to add color is to use the hue command. So hue takes in any number between 0 and 1. Hue of 0 is red. Hue of 0.1, we start to get into the yellow. Hue, when you get up to 0.8, we're in the purple. And going up to 0.9 is pink. And hue of 1 comes back around full circle into the red. So here's an example where we say, all right, I'd like to create a sequence of these points where I'm going to put a point at 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0. And I'm going to assign them to have a certain color. And the color that I'm going to assign is I over 7, so 0 over 7, 1 over 7, 2 over 7, 3 over 7. These are equally spaced numbers between 0 and 1. So if we wanted more colors, right, if we wanted to see what more of them look like, we could instead say, let's go up to 20 of them, and we'll give them hues by 20. Here are the points from 0, 0 to 20, 0, and you can start to see the spectrum of colors that are assigned by hue. Another thing you can do is change how transparent the shape is using opacity. So here we basically are using the same thing, but we're also saying, let's make it so that some of these objects are transparent, and some of them are translucent, and some of them are completely opaque. So we've taken this spectrum and applied some opacity to them. All right, so I think that's enough for now. See you again shortly.